Here we're going to do the introduction of inductance and the introduction to the circuits with inductors. We have seen that Faraday's law is the induced EMF is equal to the negative time derivative of the magnetic flux with respect to time derivative. This is found also to be a proportional constant called L, and this is for the self-inductance, times the time derivative of the current. Actually, again here a negative sign. This is a constant. The derivation of this is quite complex. We could do it in other videos. Actually, that derivation is for the self-inductance. Here, the self-inductance is we have a solenoid here, for example. This is, let's say, a iron, and here we have the wire. The solenoid has a self-inductance, and if we have a loop here and another a coil and another coil, this coil can influence on this coil and vice versa with some constant that is the same either from here to here than from here to here. That is called mutual inductance, and we will talk about this later. The derivation of this is quite complex, but maybe in some videos we will see that. For now, I want to focus on how to handle circuits with inductance. So this is called the self-inductance. We know that because here we have both the time derivatives, we now can say that the magnetic flux is equal to the self-inductance times the current. Now the magnetic flux is, remember, the closed loop integral of a surface that is magnetic field dot dA. So here our surface is quite of a cycle, so it would be B R square, and this times the numbers of coils that we have, so times N. This is the magnetic flux. Now the closed loop integral of B dot dl from Ampere's law is the magnetic permeability times the current penetrating plus the induced current, that is just the dielectric constant times the permeability constant, permeability epsilon naught times magnetic permeability times epsilon naught times the time derivative of the electric flux. Here certainly we don't have any induced current, so we just have this part, this simple Ampere's law that we see in our first video on Ampere's law. So we just have that the closed loop integral of V dot dl is magnetic permeability magnetic permeability of vacuum times the current penetrating this surface. So we found in another video that the magnetic that the closed loop integral of V dot dl for a solenoid is the same as just BL. Let me call it a small l. L being the length of the solenoid. So now we have B is equal to the magnetic permeability times the current penetrating divided by N. And we also have this, that the flux, this is the magnetic flux, is equal to this, but we also have that the magnetic flux is equal to Li. So here we have BR square N is equal to L times I. Now here I will solve for I. We have I is equal to B L over mu. Oh, and this will be multiplied times the number of holes that we have. So we have here I have L times, and here I will replace it with B L N mu naught. So we have L. So we have L is equal to B R square times